Hello, everyone. Welcome to another episode of Writing MCL. I've tried to record this episode about 3 times, I think 4 times actually, and each time I ran into different problems. So let's just start simple, okay? Last time I said we're gonna do validation. I realized that validation is a halting problem, or is the halting problem, right? At least in our language, we can't do validation of types in the stack or anything like that without running the program, because otherwise we have to run the program, right? So we have to run the program either way. We might as well do it at runtime. The second thing is that I thought, okay, let's make this language more useful, okay? Right now it's not useful, okay? It can count, here, let's run the test program. It can count to like a bajillion, right? But eventually, like, it gets boring to look at the number go up, right? Like, okay, what else can we do? So how about, instead of all that, we start making it very useful, okay? So the first thing is, let's read in things the user types, okay? Let's add a new operation. Can we do that without breaking compatibility? No. Can we? Can we do that? Okay, let's just write all the values here, and then we can think about if we can break compatibility. Okay, so I think instead of writing the values here, let me actually think. So we're gonna have to break compatibility with the old binary format of the old MCL, which is this one, because it simply doesn't make much sense. This is not a useful language. And I only did this to sort of, just because I was bored and I was wanting to write some C++. However, I think this could be useful. So let's add another instruction. And this instruction will be, what should we call it? Read. Okay. And what the read instruction is going to do is it's going to read a single, well, we have to think about what it actually reads, but I think it would be neat for it to read an integer string, right? And then maybe we want read binary as well to read a single byte. Yeah, read a single byte. So I want to implement these two because I think it would be cool if you could pipe stuff into an MCL program, like a binary file, and have that do something with it. For example, you could pipe a MCL program into an MCL program and have the MCL program run that MCL program, which I think would be kind of cool. But for that, we need read binary. So we need read normal and we need read binary. So how about we have read n? Let's call read n to read a number. Then we have read b to read binary. That's not insane, right? I think that's fair. Or actually, let's only do read binary right now. Let's not do the other one because I don't care for the other one right now. Okay. So read binary. And I'm also going to give all these values. Okay, so push is going to start at 0x. Let's do, I don't know, f0. So let's do f1, f2. Actually, we probably will have more with arguments. So let's give us a little bit more space. Let's do like e0. And this is f0. f1, f2, f3, f4, so on. Just because I want this to be like, it's easier if these are far away, then we can keep adding stuff without pushing everything around. So starting now, we can do binary compatibility with ourselves at least. Okay, so that still works. Now everything changed, all the instructions have changed, but it doesn't care, right? So that's fair. Now, if we go implement readb, the first thing we need to do is we need to write it in the compiler. Okay, so we have a few things here. The first thing is this. We want to do Right here, I think is where we want it. We want to have read B be a token of read B, and that part that tokenizes it. Okay, and then here in the instruction compiler, we want to. It's just a normal value, right? Because it's less than push. Yeah, because it's less than push. So again, like these all don't take arguments. These do take arguments, and these do as well. Yeah, so all these take arguments. Okay, what else do we got? Abstract instructions. I think this is about it, actually. We should now be able to use that in our test program. So let's take our test program and let's do read B print. See if that works. Okay, so read B is not yet implemented, right? So let's go here and let's implement read B. I did some other small refactor, like not refactoring, like basically just code quality changes, but you can ignore that. I can pretty much ignore it. It's completely irrelevant. So read B is going to read from standard in. Okay, so this is new to us because we didn't have anything blocking before. But let's do okay, so it's gonna be 0. And then yeah, we just read one byte. There's no read exact, is there? We need IO read. Some of this. And it doesn't like that because it wants a. What the fuck am I doing? There's a read UA, isn't there? Is there not? I swear there is. Fuck it. Okay. Okay, and then we just do both. And that should do it, right? No? Okay. I guess this is correct. Okay, and then we do a interpreter error standard in failed to read from standard in. With I guess with the error, yeah. So failed to read from standard in. Map error, we'll call it with the error, correct? Yes, correct. So we want to probably do that ourselves. We probably want to do error. How's that work? Does it not work like that? Oh. Wrong language. Okay. Wrong syntax for the wrong language. I've been writing, well, I read C# at work, so it's a little different. So error failed to read from standard in. Okay, and this should cause. Actually, okay, so if the read fails, maybe we want to signal that, because there's multiple reasons the read could fail. The read could fail because we reached EOF, at which point we don't actually want to exit the program. At which point we probably want to return. What do we want to return? So, I mean, we're reading 1 byte. We could add another instruction called EOF or something. Okay, right now let's just fail. Let's just fail because I don't want to deal with that. but eventually we'll deal with it. And then we'll just do self-stack push value. Yeah, that should work. So let's try that. Okay, so we printed 49 because that's one in, like, the digit 1 is a character, right? A char. And that's going to be that. Okay, so for example, what we could do is we could, what's this? 9765. So if we do plus 32, that should be kind of interesting, right? So how about we and then this should basically cause it to uppercase. So if I type an A, it should give us the uppercase value. 129 seems a bit high though. Yeah, 129 doesn't exist. What am I missing? Well, anyways, we read a byte, we print the byte, okay? And what if instead of print, we had write B that just writes the byte back out? That could be kind of cool. Could be kind of nice, kind of wonderful. Let's do that. So the reason here would be that we can have a program that basically transforms any binary file. Right. B. And that's useful. Okay, that's already useful. I just want to make this language useful. Okay, right. B. Okay. And then write B will be implemented. Write B, where we basically just want to print that to standard out as a U8 as char. Still a little funny, but I think that's gonna work, yeah. We probably want to do this instead. If let some value integer int is that. And then we want to do that. Okay, it might be a little funny to you right now, but it's going to make sense in a second. So if I enter A, it's going to print A back, okay? So what if I do this? Or let me just write some large file like target debug mclrs test. So this should have copied. Oh, okay. So it turns out we're going to be logging to standard out. That's not very good. Fuck, how do you? I want to log to standard error so that this doesn't happen. Yeah, okay. Yeah, it still happens. Oh, we probably do write or something somewhere, and we didn't replace that yet. Yeah, so we do that. Yeah, so we specify target, but then we don't. Oh no, we do. So print line. Yeah, here these. We can just get rid of these. I think. Oh well, let's leave them as debug, state or trace. And this as well, trace. By the way, I really like this feature of Z, where you can just yeah, where you can just write in the search, like just that's wonderful. And it does actually work like a suggestion. Okay. So this is basically just a copy, right? It just does like a okay, that didn't work. Let's see. Oh, because we only read one, right? We only read one byte. Read B, write B. You should just copy one byte at a time, right? So yeah. So this does like we right now we print a bunch. So let's change that. Let's do a level filter info. It takes forever, but I hear my PC spinning up, and at the bottom here you can. No, maybe you can't see it. So it says failed to fill whole buffer is because we don't actually detect EOF. We do need to add a mechanism to understand to figure that out. I think read B should return two things. It should return the byte and then also an error level or something like that. But yeah, we'll see in a second how we're gonna do that. Okay, hold on. All right, looks like my camera gave up, but I'm gonna keep going. So, but let's just see what the test file has. Okay, so the test file is not quite right, but it's something. So let's do a little bit of an easier test. So let's take our test.mcl program and write it out into that. So now test copy should have the same thing in it. It does have the same thing in it. It does. It's literally the same file. Okay, wonderful. So that's cool. That's nice. So it basically works, but it does crash out when the read B fails. So one way would be when read B fails to basically specify somewhere to jump to when it fails or when it succeeds. But I think it would be easiest to just have a jump if error, right? So jump if error. So let's do that. So jar. Sure. Let's do jar. So jar will jump if there's an error in the previous instruction, like a recoverable error, right? So let's have an error flag. That's called error flag, so it's clear. And then if this fails, same with this. If this fails, we also want that. So standard IL standard out. Actually, we probably want to have references to this because it's a little silly to call this every time. Oh, sorry. Actually, that's probably correct. Interesting. How do we do it in the other one? Oh, we write into a buffer. Okay. That's interesting. I mean, actually, we don't want that. We want standard out, right? No, it is correct, yeah. So we do actually want to have I'll right. I think that's all we need, right, for this to work. Where is it? Where did we go? There it is. And this is failed to write to standard out. Yeah, and that should work. We need to, of course, write the error string for this, but that's fair. Works already. And oh, of course, I just realized this is not even what we want. We want to ignore the error. We want, no, not ignore, but like if is error flag is true. And yeah, if error flag, then we do that. So the reason here is basically, let's see. So the reason I want to do this is because I feel like it would be nice to have feedback in the normal case where you forget to check, right? So it'll fail once and it'll fail again. And then so that way you get feedback. But same thing. So you want feedback in the case that it sort of, actually, what the fuck am I doing? I'm stupid. Yeah, what the fuck? Okay. But basically, right, we want to set the error flag, and only if the error flag is already set do we want an error, right? Because otherwise we'd run into weird issues. So, oh, I didn't implement any of these. That's weird. I swear I could have sworn I've implemented these, but I guess not. I guess they don't. I guess they don't matter. Yeah, so it still fails. And now, actually, if the write fails, we want to error out. But let's see. Yeah, okay, that works. So that seems to work pretty fine. And now if the writing fails because we're writing into, what could we write into that's a limited size? Or something we can't write into. So let's do chmod a minus w test copy. Yeah, so, well, actually that's giving us permission and I don't know. It's like, well, not gonna bother with it. But yeah, so this should work. And now we can read and write data, right? And we can also modify that data. So for example, we could have and then write that. So we could sort of add a, or what I wanted to do before is push 32. And now test copy should be, ooh, that's all right. What's the value of, how do I uppercase? ASCII upper. There's like plus, maybe it's 24 I do. I think it's plus something. Why do I even... I think it's 24 or 26, I don't know. No. Okay, so I'm clearly missing something, but it is what it is. Okay, so because what I basically want to do is I want to turn, oh, it's minus, isn't it? Yeah. So this minus 32, not plus 32, to uppercase it. Do we have negatives yet? I don't think we do. Yeah, look at that. So it's a little funny, but we could now check if it's equal to we don't have this syntax yet, do we? So if it's equal, I want to jump to continue. This is so fucking scuffed. I think JEQ is not, or JE is not even implemented, so probably should implement that really quick here. But the idea being like we wanna convert everything to uppercase. I mean, it's probably not gonna work. It clearly doesn't work, but it's fine. Let's try. It could be fun, right? No. If okay, so we need to pop from the stack two integers. We do that somewhere already. I think the add. Where's add? Oh, we have transform top two integers. That sucks. Okay. If is B jump. Stack empty. Okay. Okay. Push 11 JE continue. Oh, I want to dupe. I want to duplicate and then I want to continue. Yeah, nice. But it's 10, not 11. But other than that, it's yeah. Hell yeah, look at that. I mean, you know, it's not great. It's not great. It's not, it's not great. But it does sort of uppercase everything. So I mean that's kind of progress, right? Let's call it here. Let's say that's progress. And for next time I'm gonna see if my camera will work again. But that's progress. We've made it useful. That's gonna be the title of the episode for sure. All right, thank you for watching. Make sure you subscribe if you like this video because there's gonna be more, and like the video if you made it this far. Thank you very much for watching.